I have this funny feeling that you're the type of person that likes to touch things. You know, kick the tires, tug on the cables, flip the switches, pop the bubble wrap, push all the buttons. If so, this is the lesson for you. Let's take a closer look at the RidePlayer hardware to see all of the cool things you'll get to fiddle with. If we take a look at this end of RidePlayer, we've got all sorts of nice doohickeys. First, we have the built-in speaker outputs. There are 16 of these, with a positive and negative terminal for each, capable of providing 25 watts of amplified power. These outputs can also be configured to operate in a bridged mode to achieve 50 watts of power. This just requires you to enable a software setting, and then wire the speaker terminals in a rather interesting way. In this mode, the positive and negative pins of the odd channels are combined to form the positive bridge terminal, and the pins of the even channels are combined to form the negative bridge terminal. Just to the right, we have the line outputs, which are designed to interface to external amplifiers that require analog audio inputs. These are unbalanced outputs, so there are 2 pins for each channel, a signal and a ground. Just above those, we have the network audio ports, but these aren't your run-of-the-mill RJ45 ports. These are M12 X-coded connectors designed specifically for high vibration applications like ride vehicles. There are 2 of these ports available, to make it easier to plug in a computer running the Dante controller software, or to allow for multiple chains of network audio devices, ride amp, hint hint, without requiring an external switch. To the left, we have an SD memory card. This little guy is responsible for storing your show control project, which includes all of the sequences, timelines, touch panel graphics, social security numbers, and credit card information that we've stored within a single nefarious file. This card can be removed to provide an alternate method of updating the RidePlayer's configuration or firmware. The analog in connector next to it is a voltage sensing input with a range between 0 to 10 volts DC. Though this input can be used for all kinds of applications, it's intended to monitor an external power bus, like a 48-volt power rail for amplifiers. If we flip the product around, we've got even more goodies on this side. Over here, we have the power input and circuit breaker. Now, I'm not the type of guy to tell you what to do, but I strongly encourage you to connect this one, unless you want a cool looking paperweight. A 24-volt DC power supply works best. You'll need something capable of 20 amps of current if you plan on using the speaker outputs. 3 amps of current will do the job if you're just using the line outputs or the network audio outputs. The circuit breaker doubles up as a power switch. Just flick it to the up position to let the electrons flow. These shiny BNC connectors are the video gen lock input and output. These can be used to lock RidePlayer's sync system to an external video source, or to feed video gen lock to other devices from the same system. This is ideal if you have an onboard video system that needs to synchronize with onboard audio. This LTC port is the SMPTE timecode interface. There's an input and an output, both of which are balanced analog signals. This is yet another common method that can be used to synchronize RidePlayer with other devices on the vehicle. The serial GPS connector is exactly what it sounds like, and more. It houses a dedicated GPS port, which can be used to synchronize RidePlayer's system clock precisely to the outside world. It can also receive GPS telemetry, so that you can program show control triggers based on location. This is handy for applications like parades, where the parade float may behave differently depending on where it's located along the parade route. This connector also has a general-purpose serial port, which can control and monitor just about any RS-232 or RS-422 device. And now for the hidden bonus. This serial port can also output a DMX signal for controlling light fixtures. If you're as excited about this feature as I am, be sure to check out our lighting control course to learn more. The instructor is a total putz, but the course content is worth the migraine. At the top left, we have our network control ports. These are M12 X-coded Ethernet ports that serve the all-important role of controlling and monitoring other devices onboard the vehicle. This includes things like PLCs, motion controllers, like the Waggle Procommander, DSPs, RFID scanners, etc. It's important to note that these ports are completely isolated from one another, and each have their own IP address. In fact, the primary port actually has two IP addresses, one for show control communications and the other for media transfer and synchronization. This includes the ability to update audio files remotely and interface the RidePlayer to other devices using PTP or NTP network sync. The primary port also serves as the gateway into RidePlayer when using our WinScript Live software to program it. On the bottom left, we have our 4 general-purpose relay outputs. These are 900 mA dry contact relays with self-healing fuses. If you attempt to use one of these outputs to do something silly, like power a Binford 6100 reciprocating saw, the inline polymer fuse will quickly open the circuit. Once you come to your senses and plug the saw into your neighbor's porch outlet using a really long extension cord instead, the fuse will automatically return to normal. Close the circuit and quietly hope that you make better choices from now on. This last connector has 8 general-purpose digital inputs, which can be configured within your WinScript Live project to sense contact closure or voltage. In voltage mode, you can activate an input by applying somewhere in the ballpark of 5 to 24 volts DC between the terminals. When in contact closure mode, you can activate an input using a simple button contact, staple, paperclip, or the amalgam filling in your lower left lateral incisor. Now, if we take a look at the top of RidePlayer, we'll see all kinds of blinky LEDs. Right at the top, we've got an OLED display that you can use to show information from your WinScript Live project. This could be data like the currently playing cue, the system clock, etc. It could also show things like fault messages if an issue is detected. This is entirely up to you, and the possibilities are endless. These red buttons can be used to access a special menu system that allows you to view product status and configure the unit. For example, this is a fantastic way to configure the IP address before you connect to the product for the first time. These LEDs at the top left show general system status. The first is a power indicator. Now, if this one requires further explanation, it might be time to reconsider that career in competitive stone skipping. But hey, it's your call. LTC will be on anytime SMPTE timecode is being generated or received. Lock lights up whenever RidePlayer is locked on to the sync source you've configured. For example, if you've configured RidePlayer to sync to GPS, this light will turn on once full GPS lock has been achieved. The Live LED indicates when a computer with WinScript Live is connected to the product, mostly to let you know if someone is messing with your project and correcting the grammar in your comments. The serial and GPS LEDs here will blink whenever there's serial, GPS, or DMX activity on either port. The network LEDs indicate link and activity on any network audio or network control port. These lights will be solid orange when a link is detected and will flicker when there's activity. The input LEDs will light up whenever a digital input is activated with voltage or contact closure. The output LEDs will turn on whenever the output relays are energized, creating a closure on the output pins. These audio LEDs are bicolor. They'll be green whenever there's any active audio on the audio output, red if the output is muted, and off whenever they're bored and looking for something to do. On the bottom of the RidePlayer, there's a configurable mounting bracket. These brackets shift in this tucked position, but can be removed and installed in a horizontal position or vertical position. This gives you some added flexibility if space is tight on that ride panel. Well, this completes our tour of the RidePlayer hardware. Please exit the vehicle to your right and ensure that you have all of your personal belongings. We'll see you in the next lesson.